Let's look at exercise 2. Lithium carbonate is an antidepressant and it's available as 400 milligram tablets. In the British Pharmacopoeia assay, 20 tablets are weighed out and powdered. Then a quantity of powder containing 1 gram of lithium carbonate is added to 100 ml of water. 50 ml of 1 molar HCl is added and boiled for 1 minute to remove carbon dioxide. So this is a reagent that is added in excess to lithium carbonate. This solution is then cooled and the excess HCl is then titrated with 1 molar NaOH using methyl orange as an indicator. So we can see that this is a back titration or indirect titration where the reagent HCl is added first in excess, and after that the excess HCl is titrated with sodium hydroxide. The assay was carried out and the following results were obtained. The weight of 20 tablets was found to be 10.86 grams. So on average, if we take 10.86 divided by 20, each tablet is 0.543 grams. The weight of powder that was taken out for the assay was 1.5207 grams. The concentrations of HCl and NaOH used were both 1.00 molar respectively. The volume of HCl used was 50.0 ml, and the volume of sodium hydroxide that was added to reach the endpoint was 21.35 ml. Now let's perform the calculations step by step. We can find the number of moles of sodium hydroxide added by taking the concentration of sodium hydroxide times the titer volume. So that's 1.00 molar times 21.35 ml, but we have to convert this to liters, so divided by 1000. So we get 0.02135 moles. If we consider the reaction between HCl and NaOH, 1 mole of NaOH reacts with 1 mole of HCl. So the equivalent ratio is a 1:1 ratio. Therefore, the moles of unreacted HCl is the same as the number of moles of NaOH. So that's 0.02135 moles. The number of moles of HCl added to the lithium carbonate sample can be determined by taking the concentration of HCl times 50 ml, but convert the mLs into liters. So 1.00 times 50 divided by 1000, and we get 0.05 moles. Therefore, the number of moles of HCl that reacted with the sample of lithium carbonate is the moles of HCl added minus the moles of HCl remaining after the reaction. So let's take 0.05 minus 0.02135 moles. So we have 0.02865 moles. So since we know that it took 0.02865 moles to react with the lithium carbonate in the sample, we can use this to find the number of moles of lithium carbonate in the sample. Let's take a look at the reaction between lithium carbonate and HCl. 2 moles of HCl react with 1 mole of lithium carbonate. So the number of moles of lithium carbonate in the sample would be the number of moles of HCl divided by 2. Now we can determine the mass of lithium carbonate by taking the number of moles times the MR. Next, we need to find the amount of lithium carbonate in one tablet. So let's look at the results. The weight of 20 tablets was 10.86 gram. So each tablet on average weighs 0.543 gram. This number is taken by taking 10.86 divided by 20. The weight of powder used for the assay was 1.5207 gram. So if we take 1.5207 divided by the average weight of each tablet, so divided by 0.543 grams, then the amount of powder weighed out for the assay actually corresponds to about 2.8 tablets. So now back to our calculations. The amount that we have determined from the sample 1.0586 gram is actually the amount of lithium carbonate in 2.8 tablets. So the amount of lithium carbonate in one tablet, we can find it by taking 1.0586 grams divided by 2.8 tablets. So that's 0.3781 grams, or we can also say this is 378.1 milligrams. Finally, let's calculate the percentage stated amount of lithium carbonate. The stated amount is 400 milligram per tablet. So the percentage stated amount would be 378.1 milligram over 400 times 100%. And we get 94.5%. Now let's take a look at exercise 3. In the lithium carbonate example from exercise 2, the titration is repeated with a blank. So for this blank titration, the titer volume is 48.75 ml. Now repeat the calculations to determine the amount of lithium carbonate in each tablet and consider which method is likely to be more accurate. I've also posted the essay results from exercise 2 here in this box for easy reference. So let's do the calculations step by step. First, let's determine the number of moles of sodium hydroxide added to the sample. This can be determined by taking the concentration of sodium hydroxide, 1.00 molar, times the volume, which is 21.35 ml, but we need to convert that to liters. So that's 0.02135 moles of NaOH added to the sample. Since there's a blank, we also need to determine how many moles of sodium hydroxide was added to the blank. So we also do that by taking the concentration of sodium hydroxide times the titer volume for the blank. So that's 0.04875 moles. If we look at the reaction between HCl and sodium hydroxide, 1 mole of sodium hydroxide reacts with 1 mole of HCl. So the ratio is 1:1. And so the number of moles of excess HCl in the sample is the same as the number of moles of NaOH added to that sample. And number of moles of HCl in the blank is also the same as the number of moles of NaOH that was added to the blank. Therefore, the number of moles of HCl reacted is the number of moles of HCl in the blank minus the number of moles of excess HCl in the sample. So that's 0.02740 moles. Now, from the number of moles of HCl reacted, we can find the number of lithium carbonate. Let's take a look at the reaction between HCl and lithium carbonate. 2 moles of HCl react with 1 mole of lithium carbonate. The equivalent ratio is 2:1. So the number of moles of lithium carbonate in the sample would be equal to the number of moles of HCl reacted divided by 2. So that's 0.01370 moles. Now that we know the number of moles of lithium carbonate, we can calculate the mass of lithium carbonate in the sample by taking number of moles times mR. So we get 1.01243 grams. Remember that the weight of powder taken out for the assay corresponds to 2.8 tablets of lithium carbonate. So the amount of lithium carbonate in one tablet would be 1.01243 grams divided by 2.8 tablets. So we get 0.3616 gram, or we can also write it as 361.6 milligrams. Since the stated amount of lithium carbonate in one tablet is 400 milligrams, the percentage stated amount would then be 361.6 milligrams divided by 400 milligrams times 100%. So that's 90.4%.